It gained speed not because we willed it, not because something visibly pushed it, but because for a brief moment the known laws of physics seemed to waver. 3I Atlas, a body from another star system, crossed its closest point to the Sun, and suddenly its velocity shifted. An acceleration so slight it could be a whisper, yet significant enough to rewrite its trajectory. The calculations confirm it. Gravity alone cannot account for what happened, and what's most stunning is the timing.
As 3I Atlas neared the Sun, two human-made probes were crossing the same cosmic plane. The North American Space Agency's Europa Clipper mission and the European Space Agency's Hera mission were on their routine, silent paths, distant and unaware, until, by a stroke of coincidence, the interstellar visitor entered the scene. Now everything appears to converge within a rare window of time.
Between the end of October and the beginning of November, 3I Atlas is passing through the same sector of the solar system where these two probes are orbiting. And if the alignment holds, they could touch its ion tail, a trail of particles from another sun. An event like this has never happened before. No craft built by human hands has ever crossed the wake of an interstellar object, and it might just happen without anyone realizing it in time. Signals from space are slow. Calculations arrive with a delay. As we speak, 3I Atlas moves onward, and the probes continue their programmed journeys, unable to react. Perhaps right now, at this very moment, they are passing through the same void it just traversed. A coincidence, or part of a cosmic plot we have yet to understand? In the next few minutes, you will discover why this coincidence, this improbable encounter between an interstellar rock and two human machines, could become the most extraordinary experiment of our space age. And more importantly, what is the real meaning of this mysterious acceleration that defies gravity and reignites a profound question? Is 3I Atlas truly just a comet? If you seek science without exaggeration, join our crew. Subscribe, activate the bell, and tell us in the comments what you hope the probes will find in the tail of 3I Atlas. Let's follow this together, step by step. For months, astronomers tracked 3I Atlas as if it were just another comet, until something changed. At its closest approach to the Sun, the perihelion, it defied gravity. Its predicted path did not hold. The Atacama Large Millimeter, Submillimeter Array, ALMA, detected a slight acceleration, about 0.2 mm per second squared. Too small to be felt, but impossible to ignore. This extra force nudged it slightly off its expected course, and it was enough to reignite one of the most unsettling questions in modern astronomy. What is actually moving 3I Atlas? Natural explanations came quickly. Engineer David Farnokia from NASA's Jet Propulsion Laboratory proposed the rocket effect. The outgassing of frozen materials evaporating as they near the Sun, pushing the nucleus like a natural microthruster. This is a plausible hypothesis, also supported by astrophysicist Avi Loeb. But there's a catch. If this process is real, 3I Atlas would have lost about 1/6 of its mass in just 1 month. And it is precisely in this same interval that chance seems to have prepared a second act. Between late October and early November, two human probes will be passing through the ecliptic plane, exactly where 3I Atlas is leaving its trail of ionized particles. These are the European Space Agency's Hera and the North American Space Agency's Europa Clipper. Calculations by Grant Jones of the European Space Agency show that Hera could cross the tail between October 25 and November 1st, while Europa Clipper might do the same between October 30 and November 6. An orbital coincidence, perhaps. But on a cosmic scale, these dates represent an almost impossible synchronicity. If either of these probes passes through the trail of 3I Atlas, it will be the first time in history that humanity has indirectly touched a body from another star system. And this creates a silent tension in the scientific community. Why? Unlike a planned mission, neither of these probes was built for this kind of encounter. They follow automatic protocols, guided by fixed schedules. There is no time to reprogram anything. If the crossing happens, it will be an involuntary recording, perhaps detected days later when the data is decoded on Earth. On one side, an interstellar visitor accelerating for no apparent reason. On the other, two human machines crossing its path by chance. And in the space between them, the question that no one can answer. Is this a casual encounter or the first physical contact between our engineering and the unknown? Behind the calculations and hypotheses, there is a fact that no one can ignore. 3I Atlas accelerated independently of gravity. Data from the ALMA observatory confirmed a slight discrepancy between where it should have been and where it actually was on October 29, 2025. A deviation of 4 arcseconds. It seems small, but on cosmic scales, it's enough to show that something else was pushing it. Astrophysicist Avi Loeb calculated the impact of this force. If it were merely the sun's heat sublimating gases, 3I Atlas would have lost at least 15% of its mass in the process. This would mean an ejection of billions of tons of material, creating an immense cloud of gas around it, impossible to miss. But so far, this cloud has not appeared. What do we do with such a piece of data? Science begins with doubt. And it is precisely in this space between the calculated and the invisible that the most uncomfortable questions arise. If the acceleration came from the release of gases, telescopes like the James Webb and Hubble should detect this cloud in the coming months. The first observation campaigns are scheduled for late November and December, when 3I Atlas will be at its closest distance to Earth, about 269 million kilometers away. Hundreds of ground-based telescopes will also be watching. But if this cloud is not found, the natural explanation begins to crumble, and the phenomenon becomes a potential technological signature, a sign of active propulsion, similar to a trajectory control system. Avi Loeb was direct. If there is no gas, then 3I Atlas does not behave like a comet. It behaves like something that knows where it is going. This statement has divided the scientific community. For some, it is merely a philosophical provocation. For others, a reminder that we may not yet understand all forms of motion in interstellar space. Meanwhile, the bluish rock continues its silent journey, with no visible tail, no definitive explanation. And each new piece of data seems to pose more questions than answers. Everything known about 3I Atlas so far converges on a single point in time, a quiet interval between November and December of 2025. It is in this period that the universe seems to offer a natural experiment, a test that could decide whether 3I Atlas is just a comet or something entirely new. The prediction is simple but decisive. If the non-gravitational acceleration came from the evaporation of frozen gases, there must now be a massive cloud of debris surrounding 3I Atlas. It would be visible across various wavelengths, reflecting sunlight and emitting infrared signals detectable by space telescopes. If this cloud exists, the natural hypothesis wins. If not, something much bigger is at play. Avi Loeb calculated what we should be seeing based on the acceleration force measured by ALMA. He estimated that 3I Atlas would have lost at least 1/6 of its total mass, around 5.5 billion tons of gas and dust. Such an intense release would form a veritable miniature nebula, impossible to go unnoticed. The coming months will be the stage for this test. Between late November and the end of December, 3I Atlas reaches its shortest distance to Earth, 269 million kilometers. This is the point where its position favors observations from both the surface and space. The Hubble Space Telescope and the James Webb Space Telescope are scheduled to monitor the object, along with dozens of ground-based observatories and the International Asteroid Warning Network, IAWN, which will coordinate the measurements. The observations will be crucial to verify 3 things. First, whether there is an expanding gas cloud. Second, if the reflected light indicates a change in composition, signs of metals or ionized molecules. Third, whether the nucleus's brightness follows a cooling pattern consistent with mass loss. But so far, all we have is silence. No obvious sign of gas, no visible expansion. This is beginning to unnerve even the most skeptical. The situation is reminiscent of what happened in 2017 with the first known interstellar visitor, Oumuamua. It also accelerated slightly, without showing a tail, without emitting dust. At the time, experts called it a dark comet, a term that sounds more like a paradox than an explanation. And now, 8 years later, 3I Atlas is repeating the same behavior. But this time there is something different, a real chance to verify what happened. If the December observations do not show the predicted cloud, the acceleration of 3I Atlas cannot be attributed to known cometary processes. Two possibilities would remain: a yet unknown physical phenomenon, or a form of active propulsion, natural or artificial. No one knows. Avi Loeb described this uncertainty with irony. If there is no gas, then 3I Atlas behaves like something that knows where it is going. The phrase has echoed among astronomers, engineers, and skeptics. Some saw it as a provocation, others as a warning. Because if there is any consistent anomaly, a pattern of acceleration that depends neither on gravity nor on mass loss, then this is not just a comet. It is an object that responds to its environment. For now, there are no answers, only predictions, calculations, and the silence of space. But this silence is temporary. In a few weeks, new data will arrive, and with it, either the confirmation or the negation of one of the strangest phenomena observed since the dawn of modern astronomy. 3I Atlas continues on its retrograde orbit, moving away from the Sun toward the outer solar system. But its story is still being written point by point on the sensors that watch it from afar. Each image, each spectrum of light, is a line in this enigma, and with each new reading, the inevitable question grows louder. Is 3I Atlas just a comet, or is it the first interstellar technology we have ever seen pass before the Sun? While astronomers on Earth await answers about the mysterious acceleration of 3I Atlas, two human spacecraft travel silently through deep space, unaware that they may be on the verge of making history. They are machines with distinct purposes. The Europa Clipper, sent by the North American Space Agency, is destined for the Jupiter system. The European Space Agency's Hera is heading toward the asteroid belt to study the impact left by the DART mission. But by an almost impossible coincidence, both are now crossing the same orbital plane traversed by 3I Atlas. And this means that in the coming days, they might pass through the interstellar visitor's ion tail. However, there's a curious detail. So far, no visible tail has been recorded. 3I Atlas does show gas activity. Yes, spectrographs detect ionized molecules and signs of sublimation. But it doesn't display the classic luminous trail that usually marks a comet's passage. Some researchers suggest this is because the geometry of its perihelion, very close to the Sun, outshone the tail's glow, rendering it invisible to telescopes. Others believe the emission is composed mainly of light ions, transparent to visible light, which would mean the tail could only be seen by the plasma instruments aboard the probes. In other words, the spacecraft might detect something our eyes will never see: an invisible trail made only of charged particles, floating among the Sun's magnetic fields. The most recent study, conducted by researchers Samuel Grant and Geraint Jones, calculated the alignments based on the hyperbolically retrograde trajectory of 3I Atlas. The results impressed even the most skeptical. Hera could be immersed in the tail between October 25 and November 1, while the Europa Clipper would have the same possibility between October 30 and November 6. Both are positioned hundreds of millions of kilometers from Earth, orbiting on routes that, by sheer coincidence, cut through the flow of ions dragged by the solar wind from 3I Atlas. This isn't just an astronomical encounter. It's an unprecedented opportunity to detect the physical signature of an object from another star system. Neither of the two probes was built for this, and perhaps that's exactly why the moment is so improbable. They cannot deliberately maneuver to aim for the comet. They follow their programmed paths without direct human interference. If the intersection truly occurs, it will be an involuntary recording, a natural event captured by the machine's routine. The Europa Clipper's sensors could be the key. The craft carries instruments capable of measuring charged particles and magnetic fields, a magnetometer and plasma analyzers. If it passes through the ion tail, it could detect an abrupt change in ion density or a pattern of magnetic draping as the solar field lines bend around a cloud of particles, forming a signature typical of an active comet. It would be the first time a human probe has observed this phenomenon from an interstellar object. The Hera mission, on the other hand, lacks plasma instruments or a magnetometer, but its optical navigation sensors and high-resolution cameras could record variations in brightness or reflected particles in the vicinity. Even a slight increase in image noise, a single flicker, would be enough to suggest that the probe crossed a region affected by the tail. Grant and Jones described the scenario as an improbable natural experiment. They note that the tails of active comets can stretch for tens of millions of kilometers, and that even if the probes don't pass through the core of the stream, they might touch its edges, like brushing against the surface of a cosmic shadow. The most intriguing part is the timing. The window for this encounter is narrow, just a few days. After that, 3I Atlas will continue on its way out of the solar system, and the alignment with the probes will not repeat. No human-made engine would be fast enough to reposition them. Everything depends on chance and the solar wind. And if the crossing occurs, the data won't arrive immediately. The Europa Clipper will transmit telemetry packets automatically, and only weeks later will engineers be able to identify if there was any alteration in the records. A magnetic fluctuation, an unexpected particle spike, a non-repeating noise. It would be enough to confirm the first touch between human technology and interstellar matter. The probability is small, but it is not zero, and the mere possibility already transforms 3I Atlas into something more than a distant visitor. It becomes a point of convergence between chance and engineering, between curiosity and the unknown. If anything is detected, even if it's just a tiny disturbance in the data, the history of space exploration will gain a new milestone. For the first time, a human-made probe may cross the physical boundary between our sun and another star system. And perhaps we won't even know the exact moment it happens. Space rarely gives us second chances. Each alignment, each flyby, each unexpected glint happens only once and is then lost forever. 3I Atlas is one of those moments. A visitor from another sun, crossing our solar system with a trajectory so precise it seems rehearsed. And by chance or by orbital destiny, it crosses the path of two of our probes. While scientists on Earth calculate orbits and review data, time moves on in silence. 3I Atlas is already moving away from the sun, taking with it the trails of gas, dust, and mystery it left behind. But there is still an expectation hanging in the air, because what comes next could change everything we think we know about the space between the stars. The next few weeks will be an invisible threshold between doubt and discovery. Telescopes from around the world will point to the same spot, searching for traces of the gas cloud that should surround 3I Atlas, if its observed acceleration is natural. The Europa Clipper and Hera will continue transmitting data packets, recording whatever they can, without knowing what they might find. The truth, right now, is that nobody knows what 3I Atlas really is. The data points to cometary behaviors, the release of volatiles, the slight trajectory deviation, the brightness that changes with solar distance. But the numbers also support the anomalies, the unexplained acceleration, the excessive nickel relative to iron, the lack of water, the unusual polarization of light. An object like this forces science to work at the edge of the unknown. Avi Loeb calls this process cosmic modesty, the willingness to accept that we might not be the only technology makers in the universe. But he also insists, the role of science is to eliminate the impossible, not to embrace it. If a natural explanation suffices, it wins. And so far, 3I Atlas still fits within that boundary as a comet, perhaps an unusual one, but still part of the laws we know. Even so, the phenomenon leaves a mark. For the first time, humanity is on the verge of literally touching a fragment from another star system, not with our hands, but with machines we sent far away, trusting they would keep traveling when we could no longer reach them. It's a silent, almost poetic scene, two lonely probes crossing the void, while a bluish rock from the unknown passes them by, heading toward infinity. If Hera or Europa Clipper registers any change, a distorted magnetic field, a wave of ions, an electrostatic echo, that data will be more than just a number. It will be a bridge between two worlds, between what we sent out and what came to us. Even if nothing is detected, the meaning remains. Because the simple fact that we have probes in the right place, at the right instant, already shows how far we've come. Decades ago, observing an interstellar visitor would have been unthinkable. Today, we can track its trajectory, measure its acceleration, and perhaps even touch the trail of its passage. 3I Atlas may continue on its way without leaving answers, but it has already left something greater. A reminder that the universe still has ways of surprising us, and that sometimes chance is the method the cosmos uses to keep teaching us. In the end, perhaps it doesn't matter if it's a natural comet or an interstellar artifact. What matters is what we do in the face of uncertainty: observe, record, question. Because that is how science advances, one step at a time, always toward the unknown. And when the new data arrives, be it noise, silence, or revelation, we will be here together to try to understand what really happened. What is more impressive, the phenomenon itself, or the fact that we can comprehend it, even for a moment? If you want to follow the upcoming results, subscribe, activate the bell, and tell us in the comments what you think the probes will find when they cross the trail of 3i Atlas.